Hello, folks. I have a little bit of a quandary over exactly what I'm going to present. This isn't as bad as it sounds, as I have far, far more code than I could possibly show in an hour. If any of you were at my C# 7 presentation yesterday, then I had just more code than I could present in an hour, quite clearly. Today I have way, way more code. Part of the problem is, I know I've done abusing C# at NDC before, but I'm not sure whether it was NDC Oslo, NDC London, or NDC Sydney, or which NDC Oslo it would have been. So could you put your hand up if you've been to one of my abusing C# talks before? Okay, I'm reckoning that's still under half, which means I might pull out some of the old, great, glorious ones that are some of my favourites, but which you may have seen before. Apologies if so. A word of warning, do not use any of this code in production. The point of this talk isn't to have bad code, because anyone can write bad code and, just look at my day-to-day pull requests to see bad code. This is code which looks quite appealing, and you may be tempted and think, oh, how clever. And anytime you find yourself saying, gosh, that code looks clever, that should be the time that you scream and run in the opposite direction. However, it's really fun to do for a talk. I used to say this was great because I didn't commit any real C# code, but now I write C# at Google for Google Cloud Platform, so that's awesome. Having got one advert out of the way quickly, the other one is for my book. Some of you may already have C# in depth. The 4th edition is being worked on when I'm not speaking at conferences. And for this week, you can get 40% off any Manning book using the code CTW NDC Oslo 17. So please buy, you could buy C# in depth, you could buy other books, you could buy lots of copies of C# in depth. It's all good. Without further ado, and yesterday I was saying to blame Blowdart on Twitter if any demos go badly. Today, take your pick. Rob Connery, Damien Edwards, David Fowler, any of those three to blame if any of this goes wrong. And this talk usually does go wrong because I make the mistake of trying to ad-lib a bit of the code, and some of this code is so hairy and bizarre that if I haven't looked at it really recently, I have no idea what's going on anymore. It's a voyage of discovery for us all. I would like to start off with my favourite Unicode character. So I'm sure we all have favourite Unicode characters. Mine is the Mongolian vowel separator. The Unicode Consortium occasionally run a little sort of sponsorship drive, and they let you sponsor a character. And every time they do this, I go and I try to sponsor the Mongolian vowel separator. I'm quite happy to give the Unicode Consortium, $20 or whatever, to have a bit of paper saying I sponsor the Mongolian vowel separator. They never let me do it. It's really sad. But let's see what it is when we've thought about this code. So if anyone other than myself showed you this code, what would you expect it to do when we run it? What's it going to print out? Hint, it's either going to print out string x equals in initializer or string x equals in main. Any thoughts? Okay, I'm hearing enough muttering. I can't actually tell what people are thinking, but it's clear that people have thought about it enough. So the answer is you can't really for sure tell because you don't know what's in my text editor. We appear to have a variable declaration here, a variable assignment here, and then a variable read access here. And this middle one is where things get slightly tricky. If any of you nearer the front can have a look down here at the whole column and character bit, you may notice something interesting. If I just right arrow over, then things are fine. Column 18, character 18, and then we get to column 19, character 19, and then column 19, character 20, and then column 20, character 21. It's probably no surprise at this point that the Mongolian vowel separator is a character between string and X here. So the next question, that isn't a good bit. Okay. The next question is, what does that mean? What's that going to do? So I'm sure all of you have read the C# specification and the ECMA standard, which are different things. I have to say, this evening, I hope I still have some voice left, because from 10 p.m. till midnight, if you can believe it, I'm convening what I hope is going to be the last meeting of ECMA standardizing C# 5. I know we're a little bit out of date, but until now, it's been C# 2, and we are finally getting there. However, the C# spec and the C# standard slightly disagree on which version of Unicode they support. And this makes a huge difference. I believe, and it doesn't really matter if I've got these the wrong way around, that the ECMA standard says that C# uses Unicode version 3. And the C# 5 specification says that C# uses Unicode version 2. And it matters because of the history here. Oh, in fact, I've even written it down. So ECMA says 4, the C# spec says 3. And the important thing is that the Unicode vowel separator, U+180E, didn't exist in Unicode 2. In Unicode 3, it was a formatting character. This CF that's the Unicode category for formatting character. In 4, 5, and 6, it was ZS, which is sort of some kind of white space. I'm not sure whether it's all white space is ZS. And then for 7, 8, and 9, it's back to being a formatting character. The reason that's really important is, although the standard and the spec disagree on which versions of Unicode they're going to use, they do agree on one thing, which is an identifier can contain a formatting character. And when you use an identifier with a formatting character, it's sort of normalized away. It's as if the C# compiler does a replacement of all formatting characters with nothing, which means that the identifier string X with nothing else in it is equal, is viewed the same as a string identifier of string X with a formatting character in. However, if we put regular white space in, that's clearly no longer an assignment. That's now a declaration of a new variable. I'm not sure why I'm getting a squiggly there. The type or namespace string could not be found. That's kind of interesting. My guess is I've left the Mongolian vowel separator in there, and if I do that, maybe... What the hell? Oh, no, I'd still left it there. Okay, no, there's a couple of bits and pieces. So it seems that... I'm going to have to check the spec after this. It seems that you can't have... that the string keyword, because it's a keyword, not an identifier, can't have the Mongolian vowel separator in it. Let me copy and paste the Mongolian vowel separator. I think I am doing so. Yeah, then it goes wrong. So keywords aren't identifiers. Important. Oh, I've just worked out a whole other thing I can do with yield. Because is yield an identifier or is it a keyword? Well, it's a contextual keyword, so maybe sometimes it's... Oh, I'm not going to try to do it in front of you because it'll be far more fun to do it later on. I would love to be able to show you compiling this code with different versions of a C# compiler, and it's actually doing different things. I have not yet found any version of a compiler that actually treats it as whitespace, which is what the ECMA spec says it should be treated as. The reality is that Roslyn just uses whatever version of Unicode comes with the version of .NET that you're using. And I think the previous, despite the fact that the C# 5 spec says 3, the old C#, csc.exe before Roslyn came along, came with its own version of Unicode, presumably version 3, in there. So it would have thought it was formatting, and I haven't got a version of Roslyn that will work on a version of .NET older than 2014. in theory, if I use the monocompiler, it sort of should use this to be ECMA compliant and view it as a different identifier. But actually it doesn't. That's still one of my favorite things, and that's why the Mongolian vowel separator is my favorite character, because just changing from being a formatting character to a whitespace character and then back again is wonderfully evil. You know, how can a character be evil? That's how. Right, we're not going to leave strings though. I want to give you some tools here for what I'm sure is a very, very common situation, which is you want to write a string literal, but you don't have the shift key working at the moment. Or sorry, your shift 2 for a quote, at least it's shift 2 on my keyboard. Maybe it's shift quote for US keyboards and things. So suppose you can't type double quote. This happens all the time, of course. But you really want to initialize a constant string. Well, prior to C#6, you were stuck. But now we have the name of operator. So it's great. If I want to do hello world, and I want a constant, I want to print out hello world to the console. Without any spaces, because spaces make it awkward, frankly. I can do that with C#6. Just with the name of operator. You know, this isn't teaching you anything that you probably don't know already. Let's just prove that that does print hello world, and it will then print is null or empty as well. So that's name of intro, hello world, and is null or empty. And the latter of these proves that you can print the name of a member. It doesn't matter that X is null. We're not really accessing the member at all. All we're doing is saying, well, it must exist. And I think it has to be accessible as well. However, if I wanted to print out hello world, at the moment, I have to declare a method or a variable or something. And that's just annoying, having to declare something, bring a variable into scope or whatever. Fortunately, it turns out that name of works with the dynamic keyword as well. So we can put whatever we like in here. This isn't going to access anything. It's not going to do any dynamic member access to try to find hello world. It will just print out hello world. And then it's going to print out the Mongolian vowel separator and the length of Mongolian vowel separator. Now, as you might guess, there's a Mongolian vowel separator here between the N and the V, and there's another one between the L and the S. And just to prove, not that you can actually see that I'm copy-pasting, but I really am, paste into there and paste into there. And the great thing is that not only is the name of operator allowing us to use almost whatever string we want in here, it's also doing removing formatting characters for us. So when we print name of Mongolian vowel separator dot length, that will print it without the formatting character, whereas here we've got a string with all those pesky formatting characters that we don't really want. We only want the length of what we can see. So if we just run that, we should see that they print different lengths. That's entirely the wrong one. Apologies. No. Name of anything. Yes. So Mongolian vowel separator, after removing the Mongolian vowel separators, has length 25, and with it, it still has, without is 23, with is 25. I'm just going to bump the font up a bit, because otherwise people at the back may be hard pressed to see. Hopefully that okay? Yep, cool, thank you folks. Right, I'm going to go back to the agenda so I don't forget some of my favourite bits. Right, deconstructors. Any of you who came yesterday to C#7 know all about deconstructors, and in particular that we can use extension methods to deconstruct things into their composite parts, and the fact that we can use extension methods rather than just regular methods means that we can do it on other people's types, like datetime. However, there's a bit of a cultural problem here, because suppose we weren't sensible. If you're sensible, you deconstruct a year, month, day. But suppose you were a rigidly UK-oriented developer. And out of interest, in Norway, how do you format the dates? Is it day, month, year? Yeah, okay. It's the halfway sensible thing. It's clearly not as sensible as year, month, day, going in the same decreasing order of importance as numbers, but at least it's not the American approach, okay? I think we can all agree that the American approach to date formatting is just plain weird. So, suppose I work with some code that is UK-based and some code that is US-based. I've got some fiercely American friends who do some work, and we want to always deconstruct dates and times into the appropriate version for what we're fiddling with at the time. There are a couple of ways we can do this. So this is just date deconstruction. We take today and we're going into, I've tried not to give things away. They're just X, Y, and Z. And the question is what this is going to do. Well, I can't remember which way around it prints at the moment because I fiddle with this code all the time. Okay, it's doing it as the American month, day, year. Let's see if we can work out why. And I've no idea whether there's some shortcut in Visual Studio. How do you navigate to deconstruction? I don't know whether there is a shortcut. I'll just go to where I know it is. So, depending on whether the UK date format compiler symbol is defined or the US date format, you can see that we must have US date format defined at the moment. Let's just use different overloads. They're not actually overloads in that only one of these will actually be built. But if we decide that today we want to be more UK oriented, let's just define UK date format instead. And now when we run the exact same sort of client code, it comes up in a slightly more pleasant format. So that's fine if you're doing a single, you want your whole project to take on one kind of formatting. But what if you've got different modules, different class bits that want to get different formats? Well, we don't have to be quite as single, one format will rule forever. We can do it on a per class basis because instead of importing the whole of the extension methods for a namespace, with C#6 we can use using static. So we can just say at the top of this one, we're going to use isodate format, and I could have another class without changing any project-wide properties that used US date format. So this means that I can keep my American friends happy by saying, right, you can work on the code over there, and you can use year, month, day, year. I can't even think about it properly. I'll use day, month, year, and really sensible people will define isodate formatting, and they'll get the right way of doing things, which is year, month, day. So everyone wins, and no one will possibly be confused by looking at any of that code ever again. Am I right? Yeah, I did say never to use any of this stuff. ASCII art separators I'll leave. Preprocessor oddities. Let's look at one of these. There are two conflicting bits of language. A lot of these I sort of found while doing the ECMA standardization. They were bits of the language that I wasn't aware of before. And one of the interesting things is there are two ways of ignoring whole chunks of code. There are /* comments and #if preprocessor bits. So the question is, which wins? And ideally, I would show this by sort of removing all kinds of coloration in Visual Studio. But we can see, in this case, we have a #if foo and two #elses, which sort of looks a bit odd. But one of them is commented out if and only if foo is defined. But if we don't define foo, if I just remove that, at that point, this part of the code is defined instead, and this else is within the comments. And this little sort of /*/, that's a really helpful thing when you're writing code like this, because it is end or start a comment. You know, just whichever. Think of it as toggle comment, the toggle comment operator. And it's great. And the nice thing is, because of the way that it works, the bit that would be the end of the closing part is just ignored because it's within a comment now if we're starting. And otherwise, if we're ending a comment, well, we're ending with a slash instead. So, yeah, good ways to confuse your colleagues. Right. Let's talk a bit about string interpolation. Everyone fairly familiar with string interpolation from C#6? I do want to give a bit of a health warning at this point. It's possible you'll learn something in the next 10 minutes. I know that's not why you came here. I apologize, but, you know, it happens sometimes, just occasionally. So let's look at string interpolation project. In case you missed it before, all of this is on GitHub under jskeet/demo code, along with C#7 stuff and all kinds of bits and pieces. So let's start first with lambda expressions. So we know that we can use general expressions within interpolated string literals. So, you know, you can put foo.x and it will get the x property or whatever. But wouldn't it be lovely if we could just write arbitrary code in strings? That's clearly what the world has been waiting for ever since, you know, code behind and or avoiding code behind. So we can't just put things in braces. That's just not allowed. So maybe lambda expressions are the way forward, and you might guess this by lambda expressions being the title of the class here. However, if we just try to use lambda expressions on their own, that doesn't work because lambda expressions have no type. I won't go into why lambda expressions don't have a type right now, but instead they are assignable or convertible to any appropriate delegate type or expression tree type, any compatible one. So all we need to do is cast a lambda expression to, say, action or func of string, because we do need to produce a value to be printed. So if we cast this lambda expression to a func of string and then invoke it, all within the interpolated string literal, it will work. So there we go. Now, yeah, I don't think that's terribly readable. I think we can do better than that. So it's the casting that's the problem. And even though lambda expressions don't have a type, they can still have the type inferred if you're doing something with them. So I could have had, you know, func string func equals, and then this. That's fine. I don't need to cast at that point. So I was only having to cast because we didn't have any sort of context of how we were trying to use this thing. And at the same time, if we're going to have a context in which we're using this, why not just invoke the method as well, the delegate? So all I've done is introduced a local function here. It's only a local function so that I can fit it all on one screen without revealing other things. But now, when we call f, we pass in a lambda expression, and that can be implicitly converted to func of string, so that's fine. And as a byproduct, you know, we really wanted type inference here. But while we're here, we might as well invoke the delegate and return the string so that we can get rid of the invoke call afterwards. And now this is starting to look significantly like a more readable way of writing code. And the great thing is you can have whole programs like this. So look, you can have user input and everything. So what this code is going to do, I'll run it in a sec. So it will first, it's got to evaluate the interpolated string literal, which involves evaluating this. So the first thing we will see is what's your name. We'll then get to write something, and then when that's returned, we can invoke it. I'm using the cast this time just for fun, and just so that we can have the maximum number of braces and brackets at the end. Anytime that you want to find out how drunk you are, maybe see whether you can get this right first time without a compiler. Actually, I don't think it has anything to do with how drunk you are. It's just complete luck. So let's just prove that that works. So we'll see one of the other ones as well. So NDC Oslo, and it prints it. Hooray! So in fact, you could have your whole main method could be within here if you wanted. I haven't tried. Yeah, you could even do it not in a method at all and just have an empty main method and then static string x equals and then an interpolated string literal that just did everything. Why not? Okay, so that was part one of interpolated string literals. Next, I want to talk about lazy evaluation. So let's look at link first. So we think of string interpolation in a little bit of a way of link in terms of, well, we can use variables that are within, use local variables and all kinds of things, even though we're calling into string.format and things. But link has lazy evaluation. So I won't bother running this code because I'm sure you'll all understand what it's trying to do. So we have some minimum value, and then the query that we are not reassigning later just selects all the values from this values which are greater than or equal to min. So initially it will pick 4, 5, and 6. So when we print the count, that will print 3. When we change min to 2, because we're using lazy evaluation and because the min itself has been captured, when we call query.count, it will reevaluate the whole query and we'll get 4 instead because it will now find the 2 as well. Okay, everyone with me so far? Good. Otherwise, you're kind of 9 years out of date. So the big question is, clearly we want to be able to do this in interpolated string literals, because why not? And at this point, we have to start talking about formattable string. Out of interest, how many of you have run across formattable string before? No, very, very few. Okay, right, you really will learn. And this will be actually useful stuff. Formattable string is used where you want to do some of the string interpolation now, but probably not the final formatting, because you want to be able to specify either immediately afterwards or later on a different culture. In particular, you almost always want the invariant culture, because interpolated string literals, for better or worse, just use string.format without any format provider, so you get the current thread's current culture. I could rant for a long time about the design decisions around string.format, but let's leave that for another time. So that's why formattable string exists. But the interesting thing is what it does, or rather what the compiler does with it. There's actually a formattable string factory class that the compiler uses, and you can even plug in your own ones. I think you do get nasty clashes if you're already using a version of .NET that's got formattable string factory, but otherwise you can create your own, and the compiler will use it fine. It's all pattern-based. Or rather, it's all based on, I know that this type should exist. So what formattable string does is it evaluates the expressions within the interpolated string literal. So here, it's going to evaluate this highlighted expression, which calls my underscore method. And in fact, is it that underscore method? How is that getting... I'm trying to work out how that's in scope. Oh, I've got it using static. Yes, because using static's awesome. Right, okay. Yeah, sorry, I was so focused down here. So it will call this method passing in the delegate. That capture method just returns an instance of capture that remembers the delegate. It does not invoke the delegate, So we are evaluating this expression, but that in turn is not yet calling this. So we've got a lambda expression that's converted into a func of object, and we're remembering that func of object. And then when we try to turn the formattable string into a string, and I can call dot to string if I want, yeah, same deal, then it will call into, because I'm implementing iFormattable, it will call into our toString code here, and at this point we call the delegate. And the important thing is we can call toString multiple times, and because we've captured the value variable rather than the value of the value variable, if we change value and then implicitly call toString again, we'll get a different result. And I've even gone, above and beyond here, that you can even pass in a format string so that if your delegate happens to return something that can be formatted, like a date and time, we can format things appropriately. So if I run this code, I believe it should print current value before, current value after, and then take 10 times of printing out the current time in UTC with hour, minute, second, etc. Let's check that it works. Lazy evaluation. Woohoo! Again, completely pointless, but it's quite fun to think about when things are executed. Now the bit that I'm going to ask you to vote later on, whether you think this is abuse or a good use of C# features. So this comes on to, builds on what we've just learnt about formattable string, but also SQL injection. Now, you probably have some idea of what's coming, but if you saw something like that in most code, in particular, imagine that I didn't yet have the nvarchar, which sort of hints that something weird is going on. If I had that code, is it fair to say most of you would run a mile or, find the junior developer who has introduced the SQL injection attack? Actually, I'm not going to assume it's a junior developer. I think there are plenty of senior developers who have become blasé, and whether they knew about SQL injection attack or vulnerabilities before or not have forgotten over time. This looks like terrible code. On the other hand, it also looks quite appealing. This is the core of what I love about abusing C# as a talk. This is appealing because the alternative, the sort of normal, safe, boring version, would be to construct, you'd have var SQL equals, let's copy that, and make that, come on, at name, at ID, and then we'd have, let's move SQL connection up there, we'd have var command, cmd equals new SQL command, and give it the SQL and the connection, and then we'd have, cmd.parameters.add, and then we'd be repeating things, so there'd be the room for typos, SQL db type .mvarchar, .value equals name, assuming that we've got name in scope and things. And I don't like this. It's ugly. It's sort of separating where I'm using things from where I'm declaring them. So in that situation, this really has significant appeal, particularly when I specify the type, so I'm not even using the old parameter add with value effectively. So let's see whether we can get this to work. So I've started off by, this is a new SQL command. Instead of calling new SQL command, we're calling the new SQL command extension method. You might want new safe for interpolated strings SQL command, but we'll leave it for the moment. And that is this extension method. So that only takes a formattable string. And what I didn't mention before was that an interpolated string literal does have a type of string, but is also implicitly convertible to formattable string. So if you use var with an interpolated string literal, that still works fine and you get a string. However, if you do formattable string f equals and then an interpolated string literal, it does not turn it into a string and then turn it back into formattable string. It does that just the first bit of the evaluation. Evaluate the arguments and pass the formattable string the arguments and the format string with the formatting removed and sort of curly brace 0, the same thing you would pass into string.format. So we can use that here. So we'll have been given, in formattable string, get arguments will return the bits that we've got the name and ID from the variables, so that's from the expression evaluation. And the format string will be this. Well, it'll be the whole of this, but the important thing to focus on is we've got 0 here and 1 here. So this is ready to pass into string.format. Although this nvarchar has been left alone and is kind of, what are we going to do with that? Well, let's think backwards. How could we possibly get this to work? We need something. We're going to call string.format because there's no way that we're going to parse the format string ourselves. That would be crazy talk when string.format does it itself. What we want out is some SQL that looks like the SQL I typed before, where name equals @name and ID equals @ID, or at least at something. Doesn't have to be @name, doesn't have to be @ID. @p0 would be fine, and @p1. In other words, whatever the position is within the format string, that's perfectly fine as the name of the SQL parameter. The nvarchar does not affect the SQL that we're going to produce. But it does affect the parameters that we're going to produce to pass into the SQL command. And this is where things are a little bit funky, if they weren't funky already. So let's generate some SQL parameters first. Okay, so we're using an overload of select that gives us the value, but it also gives us the position within the sequence, the index if we want. And so we're creating a new SQL parameter with a name of position, and we're giving it a value. Okay, so we've got our SQL parameters and their values already sorted. We haven't yet got the SQL itself or the types of the SQL parameters. So that's just from the arguments. If we transform each SQL parameter to just a new format capturing parameter, that's an extra class that I've introduced. All it does is remember the SQL parameter in the constructor, but we are expecting these to be formatted. We know that we're going to be calling string.format and passing in this array of format capturing parameters. And we know that string.format is going to look at the SQL that we've got, or rather the format string that's got the curly brace with a 0, :nvarchar, and say, that corresponds to the first of these arguments. And this implements iFormattable. Therefore, I will call iFormattable.toString, passing in the value of the formattable string parameter. I'm now not with it myself. Yeah, no. It will call to string, passing in the format, because it's expecting the value to have its own value, as it were. It will pass in the nvarchar and a format provider. We don't care about the format provider at all. That could be the invariant culture. That could be some completely different format provider. But we do care about the format because this is where we get nvarchar. And it'll be null or an empty string. We don't really care if you haven't specified it. So at that point, we can take the SQL parameter that we previously captured and poke at the type So we're using the format string not to affect the result of formatting, but to affect the parameter that we captured earlier on. I'm spending longer on this because I think it's actually useful. Let's run the code. So we're going to print out the command text, the parameter db type and value for parameter 1 and 0. Parameterize SQL. I hope this still works. Yes. So we have perfectly reasonable. This now does not look like it's vulnerable to SQL injection. There are no values there, no apostrophes, nothing. We have P0 and we've got the right database type. Admittedly, it would probably have been inferred to be nvarchar anyway, just by default. Let's see if we can change that. If we make that text, then yeah. So our parsing is working. I think the fact that toString is modifying something, is using the format string to modify the SQL parameter and not affecting the formatting itself, is by far the most evil part of this. However, I would like to take a vote on this now, and I always do this, and I've had mixed results. How many people would be happy to use something like this? Oh, not very many. Not very many. I've seen more sort of 50-50 splits. To my mind, it really depends on what kind of team you're working with. If there's a fairly small team and it's reasonably easy to keep everyone up to speed and make sure they understand this is okay, but new SQL command stuff would not be okay, if they're a with it bunch, then I think the readability benefits of this are quite nice. If you're doing anything else, if you have any doubt in your own or your colleagues' ability to remember that this is okay and other things aren't, then stay well away. Okay, didn't mean to close that. Cool, let's look at some performance. I actually ran this code earlier on because every time I run it, it seems to give different results. Or rather, every time I come back to this talk, the results are slightly different and I have to demonstrate some slightly different things. This is another case where maybe it's useful. It's sufficiently useful that I do actually use this in no time. Let's look at the background. Okay, we have a large struct. It's read-only, as in it's immutable, as all structs should be unless they're system.value tuple. And it's quite large, so it's 256 bits wide. And ignore the fact that it says int256 as if I've implemented operators and all kinds of things. I've implemented absolutely nothing. It's just a way of demonstrating a large-ish struct. So, this is now 16 bytes. It's getting into the large territory, but in NodeTime, my date and time library, I do have structs that are this large or even a little bit larger. Sorry, it's 32 bytes, not 16. I think the largest one I've got is 40. So within the large structs class, and this is where we're going to be running code, I have a field called value. And I initialize it. It's a read-only field. I initialize it, and I have a property called total value, which I'm going to leave this not as an expression body member, just because I'm going to want to be adding some code in a minute. This is all totally fine. There aren't any tricks at this point, okay? I'm going to run a performance test. I'm very keen on performance for NodeTime, so I benchmark things quite significantly. And you may notice that there's a lot of iterations here, so that's do you know what? I can use... Well, hey, it's 1 billion. I should keep that in. That's helpful. So I'm going to iterate 1 billion times and add the total value property each time. Let's run it as it is. So this is going to take about 12 seconds if it was running as it was before. Admittedly, I'm now plugged in, which I wasn't when I was running the tests before. I don't know how much difference that makes on a Surface Book. 13 seconds. Okay, that's a reasonably long time. Let me show you the optimization I used to show that made a significant difference. And I don't know why it doesn't now. I can tell you a suspicion in a minute, but it's only a suspicion. Let's see. Maybe it'll be faster now, for no obvious reason. So, yeah, it looks like this is going to take about 12, 13 seconds again. While it does, I will start explaining why it's slow. 12 seconds. Okay. What does temp.bitszero do? Does it invoke the bitZero property on the value of the value, or, well, back when we were using value, if I undo everything, does it invoke it on the value of the field? Not quite. It takes a copy and then invokes the property. So back when we had this, okay, this code was somewhat equivalent to var temp equals value, in fact, var temp2 equals value, var temp3 equals value, var temp4 equals value. And then temp1.bits0, temp2.bits. Yeah. The compiler could optimize things a little bit better than this, because it could reuse the same stack bit and just be keeping the sum. But that's effectively what it was having to do. Why did it have to do this? Because this is read-only. Okay, the C# specification is very clear that if you call a function member, such as a property, on a read-only field, it has to take a copy. And that's because, you know I'm a nice person, but I could be doing something evil where let's make okay, this is well, I've got the syntax right. Bits1 equals value. Whatever. The important thing is we have a getter, an appallingly formatted getter, which mutates the value. If we call that directly on the field, then our read-only field would be mutated. That's bad. Okay, and this is why you can't call setters on read-only fields, because there's an assumption that if you invoke a setter, it's going to mutate things. It's a pretty weird setter if it doesn't. So let's go back to what we had. So we know that our original code was taking a copy each time before it calls the property. And it can't even, unless the JIT is being really clever, it can't take the copy once and then invoke bits0 on the copy and then bits1 on the copy and then bits2 on the copy, because if we had our evil code from before, invoking bits0 would have mutated bits1, and that's bad for if we take the mutated version. So if this is taking 4 copies, I had expected var temp equals value and then using temp.bit0, etc., to be a bit faster because it would be taking 1 copy instead of 4. And I'm pretty sure that used to be the case. But I now suspect that the JIT compiler says, oh, you're using temp equals value and then using temp. I'll just optimize that as if you'd used value directly. No, that's doing too many copies. Fortunately, there's an alternative. Let's make it read-write. Boom, about 2 seconds. 6 times as fast. This is why I have an attribute in NodeTime, so I would have something like this and read-write for efficiency, where the I can't remember whether I ever got round to writing it, but I was going to write a rosin analyzer that would ensure that I would only assign a value to value here if I'm in the constructor, and I would assume that anything I was doing, they were all pure structs, so I wouldn't be able to mutate them. So it's probably not useful for most of you, but if you are dealing with large structs and you do have read-only fields of those structs, if this is a tight loop, then consider making them read-write, but do protect yourself somehow. You really, really don't want to be accidentally mutating things when they were meant to be read-only. 10 minutes left. Right. I'm going to have a look now at old stuff. What's going to be the most fun? Let's have a look at this code. So, what's this going to do? Any thoughts? Well, you can just read it. So it sets limit to 10, and then it sets limit to 5. And then it iterates from x being 0 to limit. So, that's going to be until it's 5. And then prints x, and it seems to print x twice. So we expect to sort of see 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. In the obvious way. What we might not expect is that it prints 0 and then 0, 1 and then 1, 2 and then 2, 3 and then 3, 4 and then 4. Now you can see, all I've got here is program.cs, packages.config, that's just got some config. What can possibly be going on? Any ideas? Pardon? var is a class. Well, where are we declaring var? Sorry, in the project properties, there's just assembly info. And it's possible that assembly info declares a class called var. Maybe. It does, and it has implicit operator conversions. So there's an implicit operator converting string to var, where we basically just take the index of that and check that it's okay. So that will set our number to 5 when we say limit equals 5. Okay, so that's a start. How is this doing different things? Pardon? Scroll right? No, this time I don't have anything. There's just more licensey stuff. But good thought, and that's certainly been the case before. I've had to scroll left. I've got a whole... No, I'm not going to bother showing you. So the interesting thing here is overload resolution. So console.writeLine here takes a string and an object array, or an object, or an object and an object, or object, 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 or object array. But either way, they're all objects. It then calls to string on those values. So that's going to call whatever our var.toString does. What about this call here, though? There are lots and lots of overloads of console.writeLine. There's byte, int, long, object, string, etc., etc. And if there's happens to be a conversion from var to int, then that ends up being more specific than the implicit conversion, the reference conversion from var to object. So this implicit conversion here gets called. Why don't we, if we stick a breakpoint on here, we'll see it. Okay, fine. I wanted to be in release mode for the performance things, obviously. Right. So we'll see here. It's being called, the integer conversion is being called directly. Oh, it's also being called in order to make the limit work. But it's now the second time. Hello. It's possible I've given you entirely the wrong explanation. Let's have a look at the overload. No, it is calling the overload with X value. My guess is that for some bizarre reason, when it's evaluating the implicit conversion, sometimes Visual Studio will say, yep, you definitely want to stop on those things, and sometimes it will say, I was doing it in a different format, but it definitely is using this conversion. Let's just prove that by, if we make that return number times 2, so we'll see half as many numbers now, but we should see naught, the digit 0, 2, 4, and the words 0, 1, 2, I think. 0, 2, 6. I have no idea why that's happening. Oh, yeah, yes, I've got it. Anyone else got it? Yep. Oh, you're saying I'm nearly out of time. Yes, 2 minutes. But someone else, it sounded like someone, shout loudly. 6 is more than 5, yep, but that's fine. We only have the value 3 at that point. So I agree with when it's stopping, but why is it going 0, 2, 6 instead of 0, 2, 4? Any thoughts? Any thoughts? Come on. Yeah, but why did we miss out? So let me show you again. Right, I had expected 0, 1, and 2, but it turns out this implicit conversion and this implicit conversion are happening all over the place. So it's happening there in order to compare it, but it's also really importantly happening there. We're taking 0 and doubling it and getting 0 and adding 1 to it and setting that as the number. Fine, that's the first iteration of the loop. On the second iteration of the loop, the increment is saying, oh, well, your underlying value is 1. I'll double that and return that as 2. Plus plus gets you to 3. Set that as the value again. Oh, we've got 3. So that teaches me not to do really, really crazy stuff in there. I'm going to undo that before I forget, because it would be terrible to... Okay, there we go. So all of that was to talk about the implicit conversion is being used in there. So you might think that a reference conversion, which is something that is does not change the representation at all, is always more specific than anything else. But no, it turns out that if you've got an implicit conversion, certainly to a value type, I'd have to look at the exact details of the spec as to what ends up being counting as a better conversion. That's better than conversion to object. Okay, I have 3 minutes left. Let's find what else was on the actual agenda. Okay, null conditional, very briefly. I'll only have time to show one of these. No. Logging. Logging can be nice or annoying. You don't want to evaluate a detailed error message unless you're going to log it. On the other hand, you don't want to log a rubbish error message because you couldn't be bothered to do the right logging. And interpolated strings are a lovely way of putting all kinds of information in an error message. However, if you just did the normal, if I had, supposing this compiled, because it probably won't, logger.log, log level .debug that. Okay, suppose that were even slightly valid in an obvious way, then the fact that we're using formattable string, or imagine that we had an overload taking formattable string, would not help us. We would still be evaluating this, and we'd still be evaluating that. We wouldn't be doing the string formatting ahead of time, so we could save some code there, but we'd still be evaluating stuff, and we really don't want to evaluate stuff. However, the null conditional operator, can come to our rescue here. If you write an API which relies on people being able to use the null conditional operator, you can basically turn an if block into a single statement. So normally the way of avoiding things is to say if logger.isDebug enabled, logger.debug, and then stuff. Or you write things and pass the arguments separately and let it do the string formatting. And neither of those are nice because they're not as readable. If, on the other hand, you have a logger as I've got here, with debug and info properties, which return either something that will really do logging, or null if that log level is not enabled. If we say, I don't know what the default level is for this, well, I've kind of hard-coded it, but you can imagine that it would be based on configuration. So debug's going to return null, info and warn will return actual active loggers, which means, if I very quickly, I know I'm out of time, I'm so nearly there, wrong one, I'll just run. Okay, if I run logging demo, it will log the info that I had, but not the debug, in, I believe, the most readable code that you could have that never evaluates the log string unless you want it to. That's another one that's sort of on the cusp of, is that abuse or not? It's really relying on people being happy to use the null conditional operator. You don't want to use it without. However, it's just so pretty. And on that note, I hope you've enjoyed it. Please go away and look at the code and then invent your own abuses, because I can tell you this is so much fun to do. It really is. See if you can fool your colleagues. Give them clever code that looks beguiling but is awful, or that looks straightforward but actually does gruesome things with var, or, you know, dynamic is only a contextual keyword. I've got a whole other example that deals with that. Anyway, enjoy the rest of NDC. I'm Jon Skeet. Thank you.